Ladies and gentlemen, eyes up. All bets are off now. This is Count It In. In how many ways can you choose 3 kinds of ice cream and 2 toppings from a dessert buffet with 10 kinds of ice cream and 6 kinds of toppings? Here, this is under the concept of combination because we are selecting 3 kinds of ice cream from 10 kinds of ice creams and 2 toppings from the 6 kinds. But however, it's very important for us to know here that we are not just picking 5 different objects from 16. That's the 3 kinds of ice cream and 2 toppings from 10 kinds of ice cream and 6 toppings, but we are specifically picking a certain amount of number. This is a specific type of combination because we are to dig deeper on the product of their combinations. If you're going to use, say, 5, you're going to say 16 because you have that 16 taken 5, okay, because 16, that's 10 plus 6 and 3 plus 2. This will give us amount of combination as well. However, the 16 taken 5 will not be specified as to the number of ice creams, because if there's 5 that will be taken from 16, all 5 could be ice cream, all 5 could be toppings. But here, the given here is that there should be 3 kinds of ice cream and 2 toppings. So again, this is under combination, and if you have situations like this where there are 2 different groups, you are going to multiply their specific combinations. This would mean that we are going to have 2 n's, that's n sub 1 and n sub 2, and you will have 2 r sub 1 and r sub 2 here. For our n sub 1, let's focus on the ice cream. How many kinds of ice cream are there? You have 10 ice cream. Okay? And how many types of ice cream will you be picking out from 10? You are to pick 3. For our toppings, there are actually 6 kinds of toppings, and we are going to pick 2 out of those 6 for our chosen dessert. So this would mean that we are going to solve for their independent combinations and multiply them. Take note that the formula for the combination is expressed in this manner. You have n factorial to be divided by n minus r factorial times r factorial. But this is good for both situations. In short, for the ice cream, you have here 10 factorial over, you have here 10 minus 3 factorial, because you're taking 3 kinds of ice cream from 10, and you have your r here, which is a 3 factorial as well. This will be multiplied because this is what will happen here. You should have this expression, 10 taken 3 for your ice cream times you will have 6 taken or combination 2 for your toppings. This is your 10 combination 3. For your 6 combination 2, you have here 6 factorial to be divided by 6 minus 2 factorial times 2 factorial. So our first factorial, our first combination here, this is just 10 factorial over 7 factorial, that's 10 minus 3 times 3 factorial. You would know that your process is there. If you're going to see the numerical figure 7 and 3, it will add up to 10. But not the factorial notation, okay? This is not true. Only the combination. I'm talking about the, numerical figure. I'm just talking about the figure 7 and 3. The same thing on the other side. You'll have 6 factorial over 6 minus 2 is 4 factorial times 2 factorial. So we're going to solve them separately by considering again the concept of your factorial notation. It's the condensed way of writing products of integers from 1 to n. In reverse order, you have n times n minus 1 times n minus 2 ... you have 1 here. So let me extend my spaces here. Let me go to 30 I will extend because I need spaces since I need to show the process for solving the combination, the combined combinations. By the way, if you're going to click this in your calculator just for this, it's not the same as the situation here. I'm going to compare it later together with the answer. So let's start with, let me add some spaces here. Okay. Let's start with this here, 10 factorial. Okay, let me go back to 40 to make better font size to be divided by the product of 7 factorial and 3 factorial. Your 10 factorial is this: 10 times 9 times 8. Let's just end at 7 factorial. You could do that until 1, 7 times 6 times 5 times 4 times 3 times 2 times 1. But since our denominator here already has 7 factorial, you can simply cancel that. Take note that you still have 3 factorial here. Now, I wish to, since I'm doing it manually, I wish to have a denominator of 1 instead of 3 factorial. I know that 3 factorial is 3 times 2 times 1. The 3 here can be taken from 9 because that's 3 times 3. So I could cancel that. Okay, I'm removing this because I already expressed it in this manner. Your 2 can be taken from 10. So that's 5 here. Now, your denominator is just simply 1. In short, you will just simply need to have this product, 5 from your 10 times 3. Then you have your times 8. So this is just your result for your first combination, 5 times 3 times 8, considering all the cancellations that you did. This will result to 120 combinations. But this is not yet the final answer because this is just the combination for the number of ice cream that you can select, 10 taken 3. Let's proceed to the second. That's for the toppings. So you have here 6 factorial over the product of 4 factorial and 2 factorial. Again, your 6 factorial can be expressed in this manner. 6 times 5. Let's end at 4 factorial. So we can cancel the 4 factorial at the bottom. So you have your 4 factorial here. You could cancel that. You still have 2 factorial here. But your 2 factorial is 2 times 1. So with 6 here, divide by 2, I have here 3. Okay? Now that I have a denominator 1, it's easier for me to multiply my numerator. Sorry, that's a 3 times 5, which will give me a result of 15. 15 combinations for 6 toppings taken 2. Now, we can just return to our original problem here. Okay, this one here. And substitute the answer. For 10 taken 3, you'll have 120 combinations for your ice cream to be multiplied with 15 for your number of combinations for your toppings. So the answer to this problem is 120 times 15. You will have 1,800 possibilities or 1,800 combinations. This is actually the answer to our problem here, talking about number of ways we can select 3 kinds of ice cream and 2 toppings from a dessert buffet of 10 ice creams and 6 kinds of toppings, 1,800. Now, this again is not the same as this one here because the specifications are given. But this time, if you just want to compare, that's 16 taken 5. Okay, you would see the result, which is 4,360. Sorry for that, 68. As you can see, this is a lot as compared to this because for our situation, the number of ice cream and toppings were specified. But for this given, if you're just going to jump on this without using the product, you will have a different answer because you're considering all possible combinations. Take note that if you have 16 taken 5, you're only taking 5, so you can take all 5 ice creams or all 5 toppings at once. But here it's specified that there should be 3 kinds of ice creams and 2 toppings. That's why it's even smaller than what is the result of this. So again, the answer for this item is 1,800 combinations. And that's Count It In. talking about getting the luck of the draw. For all in, subscribe now.